to the smartest humans, smaller bacteria, and poisonous mushrooms, one thing that unites all life on Earth are linked to carbon chemistry. Carbon chemistry has its own branch of chemistry called as organic chemistry. Carbon, which is not the most abundant, but rather it's oxygen, and neither does it have more stability like helium. Yet our body composition has 20% of carbon, whereas it's present only 1% in the mass of Earth's atmosphere and oceans. So the question comes, why? Why does our body have a concentration of carbon of 20 folds? There are other elements like oxygen, silicon, and nitrogen which are in abundance. But big question is why? Why? Let's find the logic why nature has chosen carbon only. There are 94 naturally occurring elements periodic table. Then why only carbon? The answer comes out due to three reasons. First, complexity, abundance, and stability. Why carbon is used to form complex structures? For this, we will have to look at the foundation of chemistry, which is physics, and that too specifically quantum mechanics. Quantum mechanics explains some electron orbital configurations which are very highly energetically favorable than others, and thus they are very stable. Noble elements or noble gases have a stable electronic configuration as they have lowest of energy. They have a complete octet and they are highly stable, and they do not share or donate the electrons to form any bonds, and thus we can say they are chemically inert elements. Now we shall see covalent bonding in water molecule, where oxygen shares electron to come to its nearest inert element, neon. Carbon can share electrons with many other elements to form different compounds. Elements in the periodic table are arranged such a way that we can predict the valency of elements. Like group 1 has valency 1, group 2 has valency 2, followed by group 3 which has 3 valency, and group 4 which has 4 valency. After which the valency of the elements group 5, 6, 7 decreases. Thus we can see carbon can form the maximum number of bonds, that is 4 valence electrons. Thus it requires 4 electrons to form a complete octet. Imagine, after forming a complete octet, it comes to its nearest inert gas element, neon. Imagine when 4 pillars are made instead of 2, it would impart more stability. Carbon can form 4 bonds with other 4 atoms, thus forming a complex molecule necessary for polymers. Rings and single, double or triple bonds. The carbon atom can form vast molecules and can form polymers chain, like in the case of DNA. A DNA that carries all information has 4 nucleotides. They are basically made of carbon. Oxygen, which is the most abundant element can form two bonds only. While boron can form three bonds, so it can form complex molecules. But the problem is boron is extremely rare element. Now comes the second factor. Why carbon is chosen by nature is abundance. Carbon, which is abundant in nature. The top 5 abundant elements are hydrogen, helium, oxygen, carbon and nitrogen. So is the case in our solar system, where similarly hydrogen, helium, oxygen, carbon, nitrogen. And similarly the top 5 elements in our body are oxygen, carbon, hydrogen, nitrogen and calcium. 4 of the top 5 elements of the solar system are part of our body. Thus, why life is based on carbon? You can't build a house if you don't have enough bricks. Thus, why not silicon, which is in abundance, which can form 4 bonds, or nitrogen, which can form 3 bonds, which is 78%. Why can't they be used? Thus, the third factor which comes into picture is stability. That is bond stability. In the periodic table, all elements are placed in the group with having similar properties. In group 14, it is expected that silicon and germanium would have similar properties as that of carbon. Silicon also forms 4 covalent bonds. Thus, for every carbon molecule, there can be a similar silicon-based molecule. Silicon, which is abundant in nature, much more than the amount of carbon. Silicon has 3 shells while carbon has only 2 shells. The difference that valence electrons are far away from the nucleus in case of silicon, while in case of carbon it is much closer to the nucleus. Thus, the silicon-silicon bonds are weak and less stable. The silicon-silicon's bond strength happens to be 196 kilojoules per mole, while carbon-carbon molecule has 334 kilojoules per mole. The nitrogen-nitrogen bond strength is nearly half that of carbon-carbon bond. A skyscraper requires a very strong structural support to hold walls, windows, etc. Similarly, in the organic molecule, the bond has to be strong to withstand different conditions, giving products. The CC scaffold should be strong enough, while the functional groups break apart. The silicon-nitrogen backbones can easily break apart. In periodic table, if we look at the first 3 periods and remove the inert elements, followed by removal of elements which can't form more than 2 bonds, and then to remove those elements which are low in abundance, and then we come down to 3 elements like carbon, nitrogen and silicon. And if we remove those elements, those can't form strong bonds, then only choice is carbon. Thus, carbon has the best combination of abundance, complexity and stability. Heavier elements like germanium 10 are more rarer. Germanium, you can say, is approximately 5 folds rarer than carbon. while silicon is even more rare. If water is too cold, then it forms ice and it will be difficult for chemical transport. And if it is too hot, then the chain will break apart down easily. Thus, pressure and temperature should be proportional for life to exist in water. Thank you. Thanks a lot.